Good evening, this is VK3EKH, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast, coming to you from the studios of VK3CSJ in Narre Warren South. A very pleasant good evening to everybody who's tuning in for the first time and has tuned in already. Here on the 4th of August, a new month, and we have some sky notes tonight from Dr. Tanya Hill of the Planetarium, and a few other articles which hopefully will keep within the hour, but we never know. Anyway, we're broadcasting on prime frequency of 3541 kilohertz in the 80 meter amateur radio band, and also streaming to the internet on YouTube, my YouTube channel, which can be found on VK3CSJ. Just type in VK3CSJ in the Google search engine and look for the live symbol. And we're also broadcasting via the Melbourne TV repeater VK3 RTV Digital Channel 1 on 445.5 megahertz DVB-T2. Located just up there at Mount View, but just behind the Police Academy. 100 watts out on DVB-T2, so HD. So welcome to everybody watching the TV repeater. And I haven't checked, but there should be also a BATC feed as well. The British Amateur Television Club video server has a stream, and if everything's running okay, there should be a stream on that particular server too. Anyway, good evening. Trust you're all feeling fine and the weather is good where you are. The moon is up, about 30 odd degrees in the sky right now and looking bloody good. So it's been an interesting week for the old moon. Anyway, but that's another story. The Astronomical Society of Victoria was founded in 1922 and comprises over 1,600 members scattered about Victoria and other states of Australia and overseas. Membership of the Society is open to all persons with an interest in astronomy. The Society's objectives are to encourage the study and practice of astronomy and to disseminate the knowledge of the science and to provide greater facilities for the study among its members. Monthly meetings are usually held on the second Wednesday of each month, except in January, the latter being held on a Saturday night. Meetings start at 8 p.m. at the Maulia Hall, National Herbarium, at Burwood Avenue, Melbourne, near the Melbourne Observatory, and which is located not too far from the Shrine of Remembrance. Parking is available in Burwood Avenue, Dallas Brooks Drive, and the surrounding streets. Admission is free, and visitors are most welcome. In fact, there is a monthly meeting coming up this following Wednesday, on the 9th of April, and there is a talk going to be held there that night, on Wednesday night, which is, they're calling it the Astro Talk. The Astro Talk is going to be pulsars, nature's wonderful cosmic clocks, which is slated for this coming Wednesday, and it's the presenter is someone by the name of Rami Maddow, and he's a first-year PhD student at Macquarie University, CSIRO, working with the Parkes Pulsar Timing Array Project. He and the team lead studies some of the exotic objects, nature's exotic objects, rapidly rotating neutron stars that emit beams of radio waves from their magnetic poles, known as pulsars, using Australia's loved iconic radio telescope at the Parkes dish. In this talk, Remy will take us through what pulsars are, how they form, and what scientists use them for, including touching on the recent use of the detection of gravitational wave background. He'll also walk us through his current research on his favourite pulsar, which did something very unexpected back in 2021. So this 8 p.m. this Wednesday night. 8 p.m. this Wednesday night, there will be a live transmission to YouTube on the ASV's website. So just go to the ASV YouTube website and look for the live indication for this coming Wednesday, and also on Facebook. If you're on Facebook, the ASV's homepage on Facebook will also have a video feed running on their Facebook page. So if you can't make it into to the club room or to the meeting hall at the National Herbarium, Mollier Hall, then by all means you can tune into those live feeds. So that's next Wednesday. Rami Mandau talking about pulses, nature's wonderful cosmic clocks, and I might see if I can try and get in. It's been a quick while since I've been at the monthly meetings, but it is a journey into Melbourne, so it just depends on how I feel on the night. Anyway, so that's next Wednesday. Of course, privileges of membership include the right to borrow books, periodicals and other publications from the Society's extensive library located at Melbourne Observatory, receipt of the ASV magazine Crux containing articles, news, observing notes and the like, and the free provision of the Astronomical yearbook. In fact, the latest magazine has come out. It arrived in the mail, I think, Wednesday. So as I hold it up to the camera, for those watching the visions, that's the latest magazine called Crux, and it's already I've already had a quick scan of it, and there's quite a number of interesting articles in there. Everything from Mark Asterio, our Ascaro, our ASV president's editorial. Which is giving us a really good rundown of what's forthcoming in the society, and a bit on gravitational waves and the outer planets by Steffi Bernard, a 2-page article on help preserve our dark sky, another go at the light pollution that's going on around the place. Now, here's an interesting one. Here's a profile, an ASV member profile on Eddie Pang, P-A-N-G. Occasionally I see Eddie's work, photographs, photography published on Facebook page, and I've always made comment to Eddie how absolutely gobsmacked I am at some of his images. Well, here's a profile on Eddie in this month's Crux. And there's a picture of him. I'll just hold up to the camera. It's that's best I can do, but this is some of his images that he takes with his telescope. Some of the images that I'm hoping to be able to do as well for with my observatory, and I finally get it all up and running in a few months' time. But you can see those images there that are from his fantastic telescope, which is also on the other page here. If I can just get the magazine around in front of the camera, that's Eddie there, and his telescope that he uses. Now it's only a small telescope. I'm hitting the microphone boom here, so those funny noises you might hear is just the springs on the boom. But that's Eddie there, Eddie Pang, and his telescopes that he uses, which is really amazing. That with that setup, he can get these amazing images. I just think that's really outstanding. A lot of it, of course, is in the post-processing side of things, but there it is. So that's an interesting one on Eddie, and maybe I can read that out, that profile out another day. Then there's something on the eclipse, recent eclipse, and also a couple of things on two amateur astronomers that have won a competition, an astrophotography competition. Steve Boddy and Sean Robinson. Sean is one, but the other fellow was Tristan. I forget his surname right now, but I'm about to go into it. So, but there's something on him in there. And some more pages here on astrophotography images. It's just outstanding. And of course then there's the calendar of events, which I'm about to go into with Sky Notes. So anyway, there it is. It's the latest Crux, and nice publication, nice and glossy colour. It's really quite good. All right, having said that, so we... where are we with this? I haven't finished that, have I, really? Members are also encouraged to make use of the Society's country property located near Heathcote, some 90-minute drive north of Melbourne. There are a range of instruments available for members to use, the larger ones with appropriate training, of course. Also located on the site is a fully steerable 8.5-metre radio telescope, which can be accessed to members as well with involvement through the radio astronomy section. Members are encouraged to make and use telescopes. Advice and help on both matters are provided willingly to newcomers desiring to do the same. Instrument making is only one of the number of common interest activities catered for within the Society. Other areas of interest that members can participate in include deep sky observing, astrophotography, lunar and planetary observing, auroral, meteor, comet, radio astronomy, computing, cosmology and astrophysics, historical studies and research in astronomy in general. Contact details for various section directors are provided in the yearbook. Further information may be obtained by visiting the ASV's website at www.asv.org.au, and notifications of events are given in the Crux Extra Bulletins, which is an email that's sent out every other week, keeping members abreast of what's coming up. And also ASV will conform to all government health directives, and ASV events may be required to be cancelled, moved or postponed as a result of those. You can write to the Secretary of the Astronomical Society Victoria, GPO Box 1059, Melbourne, Victoria 3001. But the ASV website is just as good for all that information you need to know about the Society at www.asv.org.au. Okay, it is 12 past the hour. We also have an email address I forgot to mention. If you wish to send reports, signal reports, vk3ekh@gmail.com, vk3ekh@gmail.com. And of course we also have a Discord chat window as well, which is already being slowly populated. We've got Richard VK3VRS, Steve VK3SBX and Martin VK7JAH joined in on the chat window there. And welcome back, Richard, from being off air for a number of weeks. So there he is. And we have 4 emails that have popped in too in the last 12 minutes. We've got Don, g'day Don, Stephen, the VCL Factor, and Andrew. All right, thanks guys for your reports. I can just make it out looking off camera here like I am to see that screen, which is up at an angle. Okay, no worries, just checking those reports. Cool, thanks gentlemen. Okay, so there it is. We'll see you all next week. No, all right. Now this competition thing, Australian Photographic Prize. It's funny, you know. I go live on YouTube, and 13 minutes later, I get this little notice come up from YouTube to say the channel's activated. Australian Photographic Prize winners. Now, Sidereal Trading, a astro company in Tullamarine, was helping to sponsor the prize this time around. And in this notice here, they say that Sidereal Trading is proud to have been a sponsor of the 2023 Australian Photographic Prize. The winner of the Astro Landscape category was Tristan McDonald. There it is, McDonald, I forgot that. Tristan McDonald from New Zealand. And Victoria's own Steve Body took out the Deep Sky or Deep Space category. And this year was the first time that there were 2 prizes, especially for astrophotography. And there were 433 entries coming in from 14 countries. It looks like there's a giant future for this competition, Sidereal Trading says. The prize for each of these categories was a William Optics Redcat, a William Optics Redcat 51 refractor telescope, So congratulations to both those astrophotographers. Now, for those watching the visions side of this, I can bring up the images that these chaps were won for. They are here. They are here somewhere. They are. All right. So there's Tristan McDonald's image, and what we're looking at here. Yep, there it is. Tristan McDonald. It's a double helix. A double helix. After the main aurora display on the 24th of April died down, he says, I was amazed to see this Steve, S-T-E-V-E, appear in the east and travel directly overhead to the west. He says, I quickly repositioned my tripod and shot this vertical panorama from the eastern to western horizon. He says, I feel blessed to have been in the perfect position to capture the STEVE just off to the left of the lighthouse and the Milky Way just off to the right. He says the STEVE became so bright to the naked eye it blocked out the Milky Way, and it wasn't until I started stitching this pano, as he refers to it, that I realised they crossed paths directly overhead. So that's quite an amazing image, that one for sure. Good on you, Tristan. It's excellent stuff. And Steve's image, which was this one here, just as stunning. And this one was here. Steve Body. It's a this two-panel mosaic is an endeavour to showcase the breathtaking intricacies of the Carina, that's it, got it, Carina Nebula, paired with the captivating aspects of NGC 3324. The Carina Nebula, a Southern Hemisphere exclusive, and the brightest nebula in the sky, takes a proud stand on the right side of this image. Its core bristles with mesmerizing phenomena, from towering dust pillars to compact globulars, and objects that have achieved fame through the Hubble's telescope lens. Discover the defiant finger, he calls it. Those elegant structure is beautifully portrayed. Gaze upon the mystic mountains, the colossal pillars of dust and gas, the exquisite detail captured by Hubble's watchful eye. To the left, NGC 3324 captivates us, known as the Gabriela Mistral Nebula. It mirrors the silhouette of the renowned Chilean poet, adding a touch of artistic resonance to this cosmic exploration. That's Steve Body's description of his image there. And quite stunning, it really is. So I'm really pleased that they won the awards. Quite good stuff indeed. All right, let's go on to the latest Sky Notes from Tanya Hill. And I'll just bring, actually what I'll do is, I do have a picture of Tanya. So I'll bring that up now. There's Dr. Tanya Hill. And the reason why I thought I'd throw a picture of her up is that on Sunday, August 20, Tanya is at the planetarium. She's doing a presentation called Journey into the Unknown with Dr. Tanya Hill, presented by the Melbourne Planetarium for Now or Never. And the little bit of dialogue here is black holes are the opposite of existence, a fact which garners intense curiosity and intrigue. There's a film narrated by Geoffrey Rush and screened in the darkness of the Nevosphere, brings the galactic phenomenon to life in vivid detail. She says, witness all the extreme and fascinating about black holes, and after the show, hear from Melbourne Planetarium, Dr. Tanya Hill, an established member of the Astronomical Society, of Australia's Women in Astronomy chapter about the science and discovery of cosmic truth and triumph over modern science. So anyway, that is slated for Sunday 20 August at 6:15 p.m. Well, it makes it a bit late, but there you go. Anyway, more information on that, just go to Melbourne, to the museumvictoria.com.au. That's all one word there. Melbourne's, there's no Melbourne in it. Museum Victoria, museums with an S on it, museumsvictoria.com.au, to find out more information on that one. But good on you, Tanya. Nice to see you doing things out there. So, all right, we'll go back to the live cam and quickly go through the sky notes. Go back one. There we are, Melbourne Sun Times. All right. We'll go from the list, even though the 1st of August has come and gone. But on Monday, the 1st of August, sunrise was at 7:21 and setting at 5:32. By Friday, the 11th, sunrise will be at 7:10, setting at 5:40. And on Monday, the 21st, rising at 6:58 and setting at 5:48. And by the end of the month, on Thursday the 31st, sunrise will be at 6:44 and setting at 5:57. So our days progressively get a little bit longer from a light point of view, and thank goodness that I'm stepping out the door in the morning into sunlight rather than darkness. Moon phases. There was a full moon on Wednesday the 2nd of August. We've all seen that, I think. There's a third quarter phase on the 8th of August, Tuesday the 8th, and then there's a new moon on Wednesday the 16th, and then first quarter on Thursday the 24th. The moon will be closest to the Earth, perigee they call that, on Thursday the 31st at 357,181 kilometres, and then on the 16th of August it'll be the furthest from the Earth, or apogee, at 406,634 kilometres, for those that are interested in that. She's got a note here about full moon at the perigee. She says on August 2, the full moon will coincide with lunar perigee, which means our neighbour will be slightly larger and a little brighter in the night sky, although the difference will be barely noticeable to casual observers. The full details and comparison of the full moon at perigee versus apogee can be found via this link. So don't worry about that link, but there it is. Planets. Mercury will be visible in the evening from 6:50 in the west at dusk before setting around 8 p.m. Venus remains visible low in the western sky after sunset, but mid-month it will be behind the Sun until later in August, when it will return as a morning star visible in the east in the dawn light before sunrise. Mars continues to be visible in the west from 6:30 p.m. before setting by 8. The red planet will appear closer to the Sun over the next 2 months before making a slow pass behind the Sun, disappearing from view for several months. Once it returns to our skies, it will rise in the east shortly before dawn. Jupiter is merging from its recent pass behind the Sun. It will be visible early in the month from 1:45 a.m. low in the northeast before fading in the north in the dawn light by 6:50 a.m. As the month goes by, the Jovian giant will be seen a little earlier each night. Saturn is about to reach opposition directly opposite the Sun from our view on Earth. It will be visible in the east from 8 p.m, reach its highest point at 1 a.m. in the north before fading to the west by 6:30 a.m. During the month, it will be seen slightly earlier each night, and on the 27th, Saturn will reach opposition. Over the next 3 months, as we overtake Saturn in our inner faster orbit, It should be a beautiful planet to observe through a telescope with a partly open view of its vast rings. And here is an image predicted to be of that. So as she says here, over the next 3 months, as we overtake Saturn in our inner faster orbit, it should be a beautiful planet to observe through a telescope with a partly open view of its vast rings. So something similar to that. Maybe not as crystal clear and sharp images as that, but at least if you can see Saturn through the telescope you've got and where the rings are angled, that's pretty much how it's going to run through. In fact, what she says here is these Hubble telescope wide field planetary camera views of Saturn from 1996 to 2000 show its changing appearance, with the planet's axis of rotation tilted 27 degrees from its orbital plane. We enjoy different perspectives of its rings. This month's opposition should be similar to the second from the left, with the ring system partly open. Okay, which is that, I think, that bottom one that she's referring to. All right, fair enough. Okay. Next, meteors. Meteors. This month's major meteor shower is the Perseids, which peaks on the 13th to the 14th of August. Although not strong in the southern hemisphere, they are fast, bright, and can leave persistent trails and come from a point below the northeast horizon in the northern constellation of Perseus. These meteors result from Comet Swift-Tuttle, which passed near the Sun in 1991, leaving a trail of particles for the Earth to regularly pass through. So it might not be too much for us here in the southern hemisphere, but there is a potential for increased meteor activity on the 13th and the 14th of August. Stars and constellations. Let me just have a quick scan of that. Okay. In the north, this month's evening skies show Virgo and Spicer, the 15th brightest star at night and 262 light years away, have moved towards the west, while Leo has already disappeared below the northwestern horizon. However, Libra, the weighing scales, is high in the north, and in the northeast is Aquila, the eagle, which with its principal star Altair, the 12th brightest star at night, which is 17 light years from us. Turning to the east, very high in the east after sunset and slowly moving overhead during the night as our planet rotates to the east, is Scorpius, which is impressive curving line of stars. The central star of the three that form the Scorpion's body is the red giant Antares at 34 light years, and the 16th brightest star at night, rising behind the following during the night as the Centaur Sagittarius with its bow and arrow forming the famous teapot asterism. Turning to the south, standing high, and there's a picture for this one, so I'll bring up that little image as well. Standing high in the southwest is Crux, or the Southern Cross. On a moonless night, and certainly away from city lights, can be seen the dark patch known as the Coal-Sack Nebula, and a vast region of interstellar dust that blocks our view of more distant stars. To its left are the pointers, Alpha and Beta Centauri, and the brightest and second brightest stars in the constellation of Centaurus, which is the other horse-human hybrid from the ancient Greek myth. Alpha Centauri is also known as Regal Centaurus with a K, and foot of the Centaur, and is the fourth brightest star in the night sky. Until very recently it was thought to be our sun's nearest neighbour at 4.37 light years. we see what appears to be one star, but a modest telescope will reveal it is in fact two, Alpha Centauri A and Alpha Centauri B, in close orbit around their barycenter or common center of mass. However bound to these two stars, but at a considerable distance, is faint, small red dwarf star Proxima Centauri, known also as Alpha Centauri C. Our nearest star system is therefore a triple system. Proxima is, as the name suggests, is currently the closest star to our Sun at 4.24 light years and hosts at least two planets. The first planet, Proxima Centauri B, discovered in 2016, is a little over Earth mass, orbits swiftly much closer than Mercury does to our Sun, and is presumed to be tidally locked with only one face turned to its star. The second planet, Proxima Centauri C, discovered in 2016, is about 7 Earth masses and lies further out in a 5-year orbit and may possess a ring system. And they've actually got a star comparison chart here, which I'll throw up as well. Just hang on a sec, gentlemen. Hang on a sec. Nearly falling out of my chair in the process. Okay, so what we're seeing on the screen here, size comparisons of the sun with stars of Alpha Centauri triple system. Okay, so you've got Sirius A and Centaurus A, and then our Sun, Centaurus B, Gliese 205, La Salie, Captain Star, Proxima, and then the size of Jupiter, all in comparison sizes there, relative. So it's they say here size comparisons of the Sun with the stars of Alpha Centauri triple system. So there it is. Pretty massive objects out there, that is for sure. You're tuned to ASB Radio, VK3 Echo Kilo Hotel. All right, what's next? Still looking south. Low in the southeast is the 10th brightest star Achernar in the constellation of Arendi the River, which sits at 144 light years from Earth, and in the southwest lies the second brightest star Canopus in the constellation of Carina, the Keel, at 313 light years. From our southern latitude, both of these stars never disappear below the horizon. Turning to the west, low in the northwest is Arcturus, the third brightest star at night, and 37 light years from us in the constellation of Bootes. Corvus, Latin for crow, sits squarely in the west in the evening this month. In ancient Greek mythology, however, the sacred bird is a raven that perches on the back of Hydra, the sea serpent. The serpent's nearby head is a little higher up in the west and marks one end of the long narrow body that snakes to the horizon in the longest of traditional 88 constellations. Okay, I'm on camera. Yep. Okay. The International Space Station, at a distance of about 400 kilometres, the International Space Station completes an orbit every 90 minutes and appears as a bright object moving across the sky. There will be mainly visible passes this month over Melbourne and central Victoria, and here are two expected to be the brightest and highest in elevation. On Tuesday, the 8th of August, there's a passing at 5:31 a.m. to 5:34 a.m. coming in from the southeast to the northeast. And then in the evening on Wednesday, the 16th, there's a passing at 6:52 p.m. to 6:54 p.m. coming in from the northwest to the east-southeast direction. Heavens Above gives predictions for visible passes of space stations and major satellites, live sky views and 3D visualizations. So visit heavensabove.com for an idea of when more passes of satellites. It's quite an extensive website. How quick this half hour goes. Okay, 10:35. I'll just run through just a handful of these dates. On this day, on the 3rd of August 2004, the Messenger mission to Mercury was launched. On the 4th of August 2007, Phoenix Mars lander was launched. On the 5th of August 1998, NASA's Near-Earth Object Program is created to detect and catalogue asteroids that approach Earth. Also on the 5th of August 1939, first person... Oh, God, because I'm sort of scanning the sentence just ahead of me here. I'm thinking, what's this? Anyway, I'm right. I'm okay. On the 5th of August 1939, first person to walk on the moon. You see, that's why I paused. I stopped at that. As soon as I read that first part, even before I read it out, I'm thinking, no, there's something wrong with that date. But then I finished the rest of the sentence. So it goes like this. On the 5th of August 1939, first person to walk on the moon, American Neil Armstrong, of course, is born. The 6th of August 2012, the Mars rover Curiosity lands on the red planet. Also on the 6th of August 1996, a meteorite from Mars is discovered in Antarctica and is said by NASA to contain possible microfossils of bacteria. On the 7th of August 1959, Discoverer 1 USA returns the first satellite images of Earth. And on the 10th of August 1675, the Royal Greenwich Observatory is established east of London. 1675. Also on the 10th of August 1990, Magellan arrives at Venus and begins radar mapping of its surface. On the 12th of August 1877, astronomer Asaph Hall at the US Naval Observatory discovers Mars tracks a clearly evident 12.6 kilometer diameter moon Deimos. Oh, I see. I'll just read that again. On the 12th of August 1877, astronomer Asaph Hall at the US Naval Observatory discovers Mars tracks a clearly evident 12.6 kilometers diameter moon. Yeah, funny how that's written, that statement. Anyway, and on the 13th of August 1898, Eros, E-R-O-S, the first near-Earth asteroid is found by Carl Gustav Witt. And on the 17th of August 1970, Soviet probe Venera 7 is launched to Venus and will send the first pictures from the surface of another planet after landing on December the 15th. Okay, and there's one more. I'll just throw this last one. There's two more with really old dates to them. I like the really old dates. On the 18th of August 1877, Mars' 22.5 kilometer diameter moon Phobos is discovered by Asaph Hall. So he's discovered both moons, it seems. Also on the 18th of August 1868, new element helium is found by Pierre Janssen from analysis of the sun's spectrum. It is now known to be the second most abundant element in the universe after hydrogen. I'm going to leave it there and I'll finish off the rest of those dates. Oh by golly, there's not many left, to be honest. Oh, what the hell, let's finish it off. There's only a handful left there. Where was I? Spectrum, sun spectrum, okay. On the 19th of August 1960, two dogs, Belka and Strelka, are launched aboard Sputnik 5, USSR, and successfully returned to Earth. On the 19th of August 1646, birth first astronomer royal John Flamsteed, who catalogued 3,000 stars, I think that is. It says starts, S-T-A-R-T-S, so it's got to be stars. There's a lot of typos in this one here tonight. On the 20th of August 1975, launch of Viking 1, first probe to land on and study Mars. On the 20th of August 1977, Voyager 2 launched to the planets of the outer solar system. And on the 22nd of August 1989, Voyager 2 discovers positive evidence of the rings around Neptune. And on the 24th of August 2006, first formal definition of planet is debated and voted upon by International Astronomical Union in Prague, resulting in dwarf planet status for Pluto back in 2006. On the 25th of August 1609, Galileo demonstrates to the Venetian Doge and officials his improved version of the newly invented telescope. And by the end of the month, the 31st of August 1913, birth of famous British radio astronomer Bernard Lovell. What a wonderful way to end that list off. So so there it is. That's the Sky Notes for August. Thank you, Tanya Hill, for writing that out and sending it to us all so I can read out once a month, which always takes up to half an hour to get through. So I know I'm not going to be able to get through everything else I've got here, which is okay. At least I've got some stuff here to go with. You're tuned to ASB Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night cast emissions coming from VK3CSJ. Good evening to everybody. Not much activity there on the Discord. There hasn't been anybody else join in. They're probably watching that horrible footy match on Channel 7 right now. I think I'll jump to the bit on Voyager. Did I save that as a picture? No, I didn't. It doesn't really matter. Oh, yeah, I don't think I did anyway. Okay. Well, as we've heard, probably, most of us at least, in the last few days, NASA loses contact with Voyager 2 after command misdirects the probe. Not good. It's every space mission's nightmare, losing contact with the spacecraft. In the best case, you recover it right away. In the worst case, you never hear from your hardware again. On July 21, controllers lost contact with Voyager 2 out in the depths of space. Now they are awaiting for a reset to catch Voyager 2's next message when it phones home. So what happened? The spacecraft, which is nearly 20 billion kilometres away, seems to be doing fine. It's probably sending all kinds of communications back to Earth, but the stream of data is bounding off into space instead of linking up with the Deep Space Network. That's because a series of planned commands to Voyager 2 inadvertently caused the spacecraft to point its antenna 2 degrees away from Earth. Essentially, Voyager 2 and Earth are not in communication. They're talking past each other. So, regaining contact with Voyager 2, not all is not lost yet. That's because the spacecraft is programmed to reset its orientation several times a year to keep the antenna pointed toward Earth. The next reset isn't for months, October the 15th. Until then, Voyager 2 is speeding along on its planned trajectory. If all goes well, the control team should hear from the spacecraft again on October 15. At this point, they are characterizing this loss of signal as a temporary communications pause. There's nothing to indicate any other problems with Voyager 2 beyond the mistaken commands. The spacecraft is equipped with high-gain antenna measuring 3.7 meters across. It communicates with Deep Space Network via the S-band or 13 centimetre wavelength channel, as well as in the X-band 3.6 centimetre wavelength. At its current distance, the spacecraft signals take about 17.5 hours to get back to Earth. That time increases as the spacecraft gets farther away, of course. Currently, Voyager 2 and its twin Voyager 1 are exploring space beyond the solar system. They launched in 1977, and for the past decades, they have made huge discoveries at planets and the outmost bounds of the heliosphere. Their image and data opened up a whole new way of looking at the outer solar system. Now, they are in the Voyager interstellar mission phase, where their data helps characterize the limits of the solar system lie and where deep space begins. Voyager 2 probably entered interstellar space a few years ago, although it still reports on conditions at the edge of the solar system. Interestingly, while Voyager 2 is out of communications with Earth, Voyager 1 is still talking with Deep Space Network. It's about 24 billion kilometres away from Earth. Ultimately, they are headed out in two very different trajectories through the stars. They have enough power to operate for a few more years, 2025 or thereabouts, to send back information to Earth about their environments. Engineers on the project have figured out a way to extend spacecraft power for perhaps a couple or more years by tapping some specific onboard reserves. Eventually, however, the spacecraft will fall silent as their power supplies run out. This current outage on Voyager 2 is giving mission engineers an early taste of what that experience will be like after the talking with these distant spacecraft for nearly 5 decades. Yes, so let's hope we hear back from Voyager 2 on the 15th of October, which I think will be a Saturday, without checking. You're tuned to ASB Radio, VK3EKH. Okay, it's what is it, 14 minutes to the hour. Let's see what else I had here. Okay, this is another thing here for, is it James Webb? Maybe not. This is courtesy of sciencealert.com. We just got the first test images from Europe's Dark Matter Telescope, and we're psyched, is the way they've got it, 2nd of August. The Lucid Space Telescope, EUCLID, Lucid, launched on July 1 on a mission to shed more light on the elusive dark matter and dark energy, has reached its destination orbit, and on Monday, its European operators revealed its first test images. The star field snapshots were taken during the Space Telescope's commissioning, a phase during which the powerful instruments are finally calibrated and therefore not representative of its full potential. And I'll just bring up that image that they're talking about here. There it is. Right. For those watching YouTube and RTV and maybe BATC. But the European Space Agency says that the tests are already show it will be capable of fulfilling its massive mission. After more than 11 years of designing and developing Lucid, it's exhilarating and enormously emotional to see these first images coming through. After blasting off from Florida, the satellite has travelled about 1 million miles or 1.5 million kilometres away from Earth to its observational orbit. From there, Lucid will chart the largest ever map of the universe, encompassing up to 2 billion galaxies across more than a third of the sky. By capturing light that has taken 10 billion years to reach Earth's vicinity, The map will also offer a new view of the 13.8 billion year old universe's history. Its visible light camera will let it measure the shape of galaxies, while its near-infrared spectrometer and photometer, developed with the help of NASA, will allow it to measure how far away they are. Then they continue, and there's another picture here that I've got in this article, which I think I've got. Yep, there it is. But when the instruments were switched on, researchers were spooked by an unexpected pattern of light contaminating the images. An investigation led researchers to believe that some sunlight was creeping into the spacecraft, probably through a tiny gap, but that it was only detected when Lucid was orientated in certain ways. By avoiding certain angles, ESA said, Lucid's imaging device will be able to fulfill its mission. Scientists hope to use information gathered to address the RACCA, R-A-C-C-A, previously called cosmic embarrassment, that 95% of the universe remains unknown to humanity. Around 70% is thought to be made of dark energy, and the name given to the unknown force that is causing the universe to expand at an accelerated rate. And 25% is believed to be dark matter, thought to bind the universe together and make up around 80% of its mass. Right. And that image is on the screen there. They say here, it's a visible light image showing the full field, and then it's zoomed in to a certain view for detail. And so there's the full view on the left side, and then the zoomed in detail on the right side. So yeah, interesting to see what comes from that observational probe. All very interesting stuff. Oh dear. Okay, oh my god, that hour's gone so quickly. Okay, where can I go to now? It's short and sweet. Oh yeah, yeah, alright, because there's a video attached to this article. Unfortunately, there's no solar report from Timothy. She hasn't released anything in the last 8 days. We can now listen into Twinkling Stars. New models reveal how convection in a star's core generates waves that change its light, and how they might sound if we could hear them. The stars sparkle in the night sky as Earth's atmosphere warps their incoming light. In truth, starlight appears steady as it speeds through space, only becoming distorted as it travels the last few miles from the top of the atmosphere to our eyes. But it turns out that that's not quite true. Stars also have an intrinsic twinkle born from the movement of gases that make them up. While the phenomenon is not visible to earthbound telescopes, researchers at the Northwestern University have developed the first 3D simulations of the way energy ripples outward from a massive star's core. The simulations show how much a star could twinkle as a result, and can even convert the ripples into sound waves we can hear. The study, published July 27 in Nature Astronomy, may bring astrophysicists closer to using telescopes to observe surface effects that reveal the inner workings of stars. Motions in the cores of stars launch waves like those in the ocean, said Evan Anders, lead author and astrophysicist at the Northwestern University, in a statement. When the waves arrive at the star's surface, they make it twinkle in a way that astronomers may be able to observe. For the first time, we have developed a computer model which allow us to determine how much a star should twinkle as a result of these waves. At their cores, stars thrive on chaos. All stars have a convection zone where gases transport heat outward, like the mechanism that drives thunderstorms. convection generates turbulence as cooling gases lower in the star's heated and in the star is heated and rises, then cools higher up and sinks again. The intense pressure at the star's core squeezes hydrogen atoms together to form helium atoms, generating the heat that sets off this process. The location of the convection zone depends on the star's mass. In stars more than 1.2 times the mass of our Sun, convection occurs inside the core. In the Sun, convection occurs outside the core near the surface instead. This turbulence can in turn generate waves of energy that cause the star to brighten and then dim again, creating a twinkling effect. Because the cores of stars are hidden, Anders and his team created a model that simulates convection inside them, and to do so the scientists looked at the properties of turbulent core convection and the characteristics of the waves it generates. Based on these waves, each simulation then accurately predicts how a star's luminosity changes. The model showed that when convection creates waves, they bounce around inside the star. Some waves reach the star's surface, generating a twinkling effect, while others stay trapped inside the star, bouncing around its interior. To understand the twinkling, Anders and his team had to isolate the waves that merged the surface. To do this, the team put a dampening layer around a model star, like the padded walls you would have in a recording studio, so we could measure exactly how the core convection makes waves, Anders said. Once the filter could accurately describe how the star changed the waves generated in the core, the team used it to create another filter of how waves should act inside a real star, with some reaching the surface. Using these models, the team could finally show what astrophysicists should expect to see through a telescope as a result. Stars get a little brighter or a little dimmer depending on various things happening dynamically inside the star, Anders said. The twinkling that these waves cause is extremely subtle, and our eyes are not sensitive enough to see it, but powerful future telescopes may be able to detect it. The sound of starlight. After successfully modelling waves, Anders increased their frequencies to make them audible to our ears. Depending on the star's physical size and convection-induced waves with sound, depending on the star's physical size, the convection-induced waves will sound different, full stop. Waves inside a larger star sound like a ray gun. Once the waves reach the surface, they change into a low hum, echoing through a vacant room. On the surface of the medium-sized star, the waves sound more like a hum across a windy field, and a small star's surface sounds more like a weather siren. Finally, using their model as an instrument, the team passed the strong Twinkle, Twinkle Little Star through various sized stars to see how each changed the sound of the song. As the stars grew smaller, the sound became higher in pitch. The stars changed the music and correspondingly changed how the waves would look if we could see them as twinkling on the star's surface, Anders said. Struth. Alright, now there is a 40-second video attached to this, so I haven't listened to it, so I'm not sure exactly what the sound side of it is going to be like. Where have I put it? Is that it there? Yeah, that's it. Alright, so this I suspect will be much better listened to and watched, of course, because it's visual as well, on the ATV repeater, and also my YouTube channel. G'day Bill, Mr. KHT is watching there as well. So I'm going to switch across to this video, and hopefully it'll make sense to those listening on sideband. Let's hope this works. I've always got my doubts about this part of the job. Oh, lots of hiss. Why is that? Just a sec. Something's got lots of audio attached to it. Listen to a star. Okay, I'll just wind that down a bit. Okay, something had a lot of hiss to it. Right. Well, to those listening to SSB, that might not have really come across much at all, but it was meant to be. It's visual. There's even text on the screen as well, which you had to read. So that 40 seconds wasn't really much worth, really. But I'll probably view it again later on and absorb the sound, because I think the sound was in the first 10 seconds of the video before the other stuff started. Anyway, enough of that. All right, let's bump up to spaceweather.com and get tonight over and done with. Where are we with spaceweather.com? I lost my train of thought. And there was so many other things I had to talk about tonight. This is an interesting one. How many satellites can we safely fit in Earth orbit? I was going to read the entire one out of that. I think I'll leave that till next week. All right, spaceweather.com. The solar wind is currently at 444.9 kilometres a second at a density of 0.18 protons per cubic centimetre. The disk of the sun, which looks like this at the moment, has several sunspots upon its surface facing Earth as we speak. 1, 2, 3, 4, 5, 6, 7, 8, 9, at least 9 sunspots that are labelled there. And there's a geomagnetic storm watch later today. A CME is expected to hit Earth, possibly sparking a G1 class geomagnetic storms. It was hurled in our direction by one of many M-class solar flares earlier this week. No one is certain which one, though. NASA and NOAA models agree that the CME should arrive near midday universal time boundary between the 4th and the 5th. Okay. The current sunspot number overall is 124. And the radio sun is currently at 163 solar flux units, measured at a wavelength of 10.7 centimetres. The KP index is 2, currently sitting at 2, which is considered quiet. The 24-hour prediction for the KP is also considered 2, which is also considered quiet. The current auroral activity over the Antarctic South Pole, Antarctica, is currently looking like this for those watching TV. So it's a little Australia directed, but nothing to write home about at this point in time. And with the current cloud cover around, you're probably not going to be able to see too much south of Tasmania, but there is still a glow in the sky down that way. Also to report is, just looking here, they're saying something marvellous about Venus. I haven't quite read this. Something marvellous is happening to Venus. If you see Venus through a telescope this week, you might not believe your eyes. The Earth-sized planet has narrowed into a marvellously thin crescent. Yesterday, a photographer took in broad daylight in Santiago, and there's an image there of a very, very thin crescent. It's only 3.8% of the planet's disk was illuminated, and he saw this at noon time through his 8-inch telescope. Yes, if you know where to look for Venus, you can suss it out during daylight hours. It can be quite bright. I've managed to do that. Took a bit of effort, managed to do it. All right, enough of that. If you go to spaceweather.com, you can see that picture. As of the 4th of August 2023, there are, or at least were, 2,335 potentially hazardous asteroids, but none of them are on a collision course with Earth at this point in time. All right, I think that's about it tonight. So thanks again, Tanya, for her Sky Notes for this month coming up. And again, congratulations to Steve and Tristan for their wings of the astrophotography side of things, all very good. And like I say, I had a few other articles which I'll keep on for next week. So thank you very much, everybody, for listening. I haven't checked my YouTube audio level. Harl, I want to. Yeah, that's okay. I haven't been distorting on YouTube, which is good. Thank you very much, everybody that's tuned in to the Discord channel. I can see there's a few folks that have added. Bill, VK3KHT. Interested, active ATV, 80 metres. Yep. Not interested in the football. Okay, fair enough. Martin is, he says, still here, Clint, still listening. He also doesn't like football, which is fair enough. And Steve, VK3SBX, just says hi all, so I guess he likes football. And Richard, VK3VRS, PC is working as it should, which means he's going to be doing ATVing very soon. And up on the email, again, thanks guys for sending me emails. All very excellent. Only if St Kilda is playing. Well, I was going to say only if Essendon is playing for me. Otherwise, I don't really worry about it. I'm a long-term barracker for Essendon since I was a little whippersnapper. But that's only because my sister barracked for Essendon. She's 7 years older than me. So I thought, well, if she barracks for Essendon, I will. So it's loyalty. It's where I've been for the rest of my life. And but I don't really pay that much attention to it. Damn it! I forgot to finish my coffee. It's been horribly cold. All right, on that note, this is VK3 Echo Kilo Hotel with VK3CSJ on the microphone. We shall now open up the frequency to a quick callback as such and see who is listening out there. And I shall get my pen ready here. And if everything is okay on the dark side of the moon, let's play the pipe tones. This is VK3 EKH listening on 3541 kilohertz, please.
VK3JR. VK3TJ. VK3SPL for X-ray.
VK5 Whiskey Alpha.
VK7JAH. VK3UZI. VK3KHT. A rather noisy signal here.
It sounds good to me. Okay, there might be one station I didn't get down. I was writing it real quickly. VK3GL, VK3JR, VK3TJS, VK3SBX. Someone in there after SBX I didn't catch. X-ray. Greg. Yep. Okay. VK5WA, VK7JAH, VK3UZI, and VK3KHT. Is there any other stations? Okay, to the top of the list, go ahead, Gray, VK3GL, VK3EKH.
Yeah, VK3EKH and the group VK3GL. Very pleasant good evening to everyone who's called in this evening. Seems like the band's in pretty reasonable shape, so was hearing everyone who called in. Yeah, good broadcast there, Clint. I listened to a fair chunk of it, working this evening. So, I was sort of interrupted with a few things with work, but generally heard most content that was talked about this evening. There's always one little thing that sort of pricks my ears up, and I think you and I have sort of spoken about it before, but this Voyager, you were talking about Voyager 2 and the loss of contact, etc., and the distance away from Earth and all that sort of thing. When you stop and think about it, like that thing's been up there for 45 plus years, or getting on to 46 years, and when you stop and think about it, the technology that was deployed to way back then, in some respects still working today, and when you think about what's occurred here in our world in that 45 or 46 years, we've had the internet, we've had all doing, and it's so far away. And to think that they, even way back then, they put in fail-safe mechanisms like it being able to self-orientate itself and keep an antenna pointed back towards Earth. As you indicated, if it's 2 degrees off, that's like millions of miles off at the other end. So it's quite remarkable, isn't it, when you sort of stop and think about what it's doing, and the fact that it's still there. Even things like just batteries and keeping them charged. The technology has changed a hell of a lot since way back then. Anyway, it's all good stuff, and I guess it's all cutting edge. It's all what the exploration is all about. That's for sure. Anyway, thanks very much, Clint. Good to catch up. I might have a brief word after the net if you're still around. Not for too long, but have a brief word if the opportunity exists. Thanks for the broadcast. Good job as always. VK3EKH, VK3GL.
Yes, okay, Graham. VK3GL, VK3 EKH returning. Very good. Yes, I agree. The engineering in those early probes, whether it be Voyager or Pioneer, the money was well spent, and the science was triple checked to make sure that things were going to work, because even in those days those projects cost a lot of money, and to get these probes to swing past Jupiter and Saturn and Uranus and Neptune and head off into space and still be able to communicate with Earth is, after all this time, it is outstanding. So somebody has done the job correctly, the little power plant on board these spacecraft using an isotope of some sort. Is amazing how it's just continuing to run things, but with these spacecraft, they are having to turn certain functions off, certain instruments off to try and conserve the power. So it'll be interesting to see just how far they do go before the signal is completely lost. But what I find intriguing also is that given the distance that these probes are out in space, that our deep space network, our Earth tracking stations, have the sensitivity to be able to detect these feebly weak signals amongst the noise. And it just goes to show how incredibly sensitive our telescopes or radio telescopes or the dishes used for the space network, well, including radio telescope dishes, how incredibly sensitive they are. And it just goes to show that in all the attempts to try and receive signals beyond our solar system, our universe, that might show something of a techno signature, it hasn't come through yet. So we're still pretty much sitting out here all on our little lonesome, for all intents and purposes. Enough of that. All right, thanks, Graham. Good evening, Frank. VK3JR, VK3EKH.
3JR. Good evening, Clint. Good evening, everyone.
Great broadcast as usual.
Thank you, Clint. The space probes and the voyages are remarkable indeed. It's such a shame we've lost track of one of them for a short time, hopefully. I heard it was due to human error. You'd feel pretty bad if you were a human, wouldn't you? If that's true. But, we all make mistakes and all that sort of stuff. Anyway, let's hope it resets itself. I don't know. There must be some feedback loop, I guess, that enables it to know when it's on track. Don't know, really. Anyway, thanks for doing it. There will be missions relatively short tonight, Clint, on 160. So talk soon and take care, and thanks again for doing it. VK3
EKH, VK3JR.
Good on you, Frank. VK3JR, VK3EKH, and I'll probably have a quick listen to that too. As soon as I'm finished here, I'll be heading downstairs, and I've got the receiver on 160 already tuned up, and I'm going downstairs. Yeah, I'll take a quick listen to that. And yeah, look, I think all the probes, in this case, both Voyagers have this routine. As the article I read out today said that every so many months there's a routine that the onboard computer system goes through does a house check. There's another name for it, can't think of it right now, but it just does a quick check of systems to make sure they're all operating. And if there is something that's a bit skew it's then entitled itself to fix itself. So that's what they're relying on the 15th of October, is this system to say, oh, hang on, we're not quite pointing the right way. Pretty amazing, though, really it is. It's just damn amazing stuff. And I think it's just a 20 watt transmitter. I think it is. I think it's 20 watts. That they use. Amazing stuff. All right, thanks, Frank. Across to Steve, VK3SBX, VK3EKH.
VK3EKH, this is VK3SBX. Yeah, I was just looking that up. Clint, yeah, I think it's 20 watts. Yeah, it's not much, is it? Mine's 130 dBm or something when it gets there. There's not much left of the signal. I did hear, though, a couple of days ago, apparently the Canberra Deep Space Network at Tyndall has picked up a hint of a carrier from it. And they're trying to bombard it with signals to get it to point back in the right direction. So they know it's still going, and it's I guess it's close enough to the correct position to just get a tiny signal from it. But pretty amazing stuff. I'm kind of wondering how it knows how to point back after the reset. You know, does it sense the position from the stars, or does it just reverse the commands it got since it last talked to the Earth? Yeah, interesting. I don't know the answer to that. All right, thanks, Clint. Interesting broadcast as usual, and we'll see you again next week. VK3EKH, VK3SPX.
Thanks, Dave. VK3 SPX, VK3 EKH returning. Yeah, yeah, I'd be interested to find out how they do that. Look, I suspect that the onboard computer has star coordinates in its database, and they probably use the onboard camera to look back towards the sun, because the brightest object in the camera lens would have to be the sun, and I suspect that the camera would pick up some sort of visual aspect or visual reference to our sun. If it's not in view, it would correct for it. I don't know. I'm not really sure how it would work, but it would be interesting to find out for sure how they do it. And hopefully, with the up and coming reports that'll come through on Voyager 2, part of that story will also come out on how it all works. Look, I thought I read something about that too, actually, that they detected a familiar heartbeat thing from Voyager, so that they knew that there is something just on the edge. Yeah, so I read something similar as well. It wasn't in that particular article that I read out tonight, though. Anyway, no worries, Steve. Thank you very much, Lee. And now it is across to Greg, VK3 Delta X-Ray, VK3 EKH.
Yeah, good on you, Clint. VK3 EKH and the net there tonight. Good evening to everyone. Yourself, Graham, Frank and Steve that I've heard so far. It was interesting. I was thinking what Graham was saying there about Voyager and what's it been up there nearly 45 years, and I was thinking, I was 27 then, and technology's how much it's changed since then, and what it's still doing. And I think to myself, I wonder how many other civilizations may have seen what Voyager's doing out there, Clint. Yeah, very interesting. Okay, yeah, good broadcast as usual, and signals are all well above the 9, so yeah, it's all good there, Clint. Okay, mate, 73s, and cheers to everybody, and we'll be about there next week. VK3EKH, VK3 Delta X-ray.
VK3 Delta X-ray, VK3EKH. Well, look, the intention with that probe is that it will go on forever. Being in the vastness of space, unless some nasty aliens go flying past and see it as a bit of space junk, I think let's fire our photon torpedoes at it for practice. It will go on forever, and the human race will have been and gone, and quite possibly our planet will have finally died out due to the sun expanding, and that probe will continue. It'll be still there, and it's carrying that record, gold-plated record, with the sounds of Earth on it. It starts out by saying greetings from planet Earth in 150 different kinds of greetings. If I remember correctly, the person that says greetings from planet Earth is Carl Sagan's son, saying that. A bit of trivia. I think that's right. It could be wrong, but I think that's right. Anyway, yeah. But of course, even though there's apparently, there's instructions on how to play the record, but it'll be interesting if some intelligent being comes across it in the far, far off, distant world, time, future, and can work out how to play that record. What an amazing thing that would be for that particular civilization. I can just imagine a science fiction film based on that scenario. Well, I mean, there's one film. It's called Starman. John Carpenter's Starman was sort of loosely based on that idea. Alien finding the probe, Voyager. Was it Voyager? Pioneer Voyager, I think, with the gold record. Yeah, Starman was a good film. I enjoyed that movie. It was all done very well. They just never followed it up with Starman 2. It should have been... Oh, there's a TV series, I believe, but never really got in... Well, I never watched that. I don't know. Anyway, doesn't matter. Enough of that. Thanks, Greg. Across to Dallas, VK5WA. Dear, VK3EKH.
Oh, yeah, g'day, Clint. Yeah, big signals here tonight. Really good. Excellent. Let me just turn you down. You're running in delay there. Quite a big delay. That's the trouble with digital. Thank goodness Voyager's mostly analog. Put it this way, probably as reliable as a good old 820, 520, and even a 101, I suppose, and others. They've got some pretty old resistors and things in them. Surprising that, I've got one here, it's still going. Well, since about the same time it was launched, isn't it, in the early 70s, 1976, 72, 73. So, as far as propagation and receiver sensitivities and all that sort of stuff, nothing's changed much there, except we don't have to run them in liquid nitrogen as much now. But I think that, the Deep Space Network, it operates GLTs that are optimal, temperatures of 10 Kelvin, so or 10 or 15 or whatever it is. And after all, the background is only a couple of degrees, so a couple of Kelvin. So if you're looking at a cold background, good thing it's not flying near something warm. So I imagine it does lose it. So they're up against a cold background, and it's probably looking back this way, except the sun is a fairly small object now, so its flux density is fairly low. And 2 degrees, well, that's as far away as the sun is out there. That's like 200 million kilometre off pointing. and the beam is only about 0.7 degrees if it's a 3.7 metre dish. It's X-band, so it's about 100 wavelength dish, so fantastic stuff. And comment about batteries, I wonder if it actually has any batteries at all, because the thermal generator, it just keeps on humping away there, and it's just a feedback effect, isn't it, or Petlier type thermal generator. 400 watts, or probably down to about 300 watts now or something. It says 90 years half-life. People talk about technology, but if anything, technology's only got better through smallness and making lots of small stuff. And of course, it wouldn't have lasted 6 months, any of the new small stuff that goes out there. That's why they've got to put so many of these damn things up, isn't it? Look at how many of Musk or all the others are putting up 20,000, because they only last 6 to 12 months. Through decay, or maybe they want a better one, or maybe the processes are too. That's the trouble with a lot of these projects they're putting up. Look at all the latest XA, the Chinese/British satellites. They're all made out of modern processes, and they just don't survive. So, and the other comment, the gold record, well, that was wishful thinking. No, nobody's going to find it. What is it, 40, 50,000 years to reach the nearest star, which is it's 4 light years away. So, it's very wishful thinking that, in fact, I don't think there's ever, I can't imagine ever be found at all, given it's so small, moving so fast, and most of space is empty. So, and even at the end of time, as you said, Clint, what's that? The Earth fails in 1 billion years if the oceans don't get too hot for us in the next 20 years. In 1 billion years it won't even be anywhere. It'll only be still a dot in the galaxy where it's been. So space is big. It's wishful thinking gold record. Anyway. All right, good old Clint. Excellent broadcast. VK5. VK3EKH. VK5WA.